This video is on measures of dispersion. Measures of dispersion measure how spread out a dataset is, and there's a few different ones that we can look at. So we have the range, which is the maximum value minus the minimum value. The standard deviation, and we use that symbol there, gives an idea of how data values are spread in relation to the mean. The variance, which is the standard deviation squared. The interquartile range, which is our upper quartile minus our lower quartile, Q3 minus Q1. Just a note there with the quartiles, so when we have the data values in order from lowest to highest, Q1 is the data point 25% of the way through the data, and Q3 is 75% of the way through the data. With this, we also need to be aware of outliers. So an outlier is a value that is much smaller or much larger than the other values. Now we can work out if a value is an outlier by using the formula of 1.5 times the IQR, the interquartile range, and then we add that to the quartile 3, or do the quartile 1 subtract the 1.5 times interquartile range to work out what that point is as to whether something's an outlier or not. And we'll do that in some examples. Alright, example 1. The following data sets find the standard deviation, variance, range and interquartile range. Part A, the number of ice cream sold over a period of 13 weeks is as follows. Each of these, we're actually going to do these on our calculator. So I'll head over to the calculator screen now to show you how to do the first one. Then we're just going to go to our spreadsheet and put our data in the columns for this first example to be able to find out the information we need. So I've got all my data in there. I'm going to go to the exact same spot as we did in the mean, median and mode video to get to our information. So menu, statistics, stat calculations, one variable statistics, data's in column A, results in column B, that all looks good. Okay, now we need to find out which parts of this we need to look at for all the information. So the first thing was a standard deviation. So now on your calculator for standard deviation, there are actually two. We have this one and this one. The one that we need for in IB exams is this second one that I'm on here. And so always look for this symbol that we always use to represent standard deviation. So our standard deviation for this set of data is 30.838. Now for the variance, this is not on this page, but we know from the information we just wrote down before, variance in standard deviation squared. So we just need to square this number. One thing to note with this calculator is the spreadsheet application that we're in now works just like Excel. So I'm just going to go to the cell next to where my standard deviation is. I'm going to type equals, and then the cell where the standard deviation is in C6. So we'll type C6, and we want that squared. And so to square on your calculator, you can just hit squared. So we're telling the calculator now to square cell 36, which is the standard deviation. Press enter, and there you'll see our variance is 951 to 3 significant figures. It's a great little tool if you know how to do this, because you can do things much quicker than trying to copy down numbers and go back to a calculator page to solve. So remember, just press equals first, your calculation, and you're good to go. Okay, for now the range, we want our maximum minus our minimum number. So I'm just going to scroll down. So we've got our 5-number summary there. We want maximum minus minimum. Our maximum there is 238 minus 146 will give us 92. You can do that on a calculator, or once again we could use a function. So we can press equals. Our value for the max is in cell C12, so we'll type C12, minus our minimum, which is in cell C8. Press enter, and there you go. You see we've now got our range. And the interquartile range is always Q3 minus Q1. And we'll do the same thing here, so press equals. Our Q3 is in cell C11, and minus Q1, which is in cell C9. And then we can get our interquartile range, which is 38.5. We're going to go write those down now in our notes. So these are all our solutions for part A. You'll see for each of these I've written a longer decimal number, minimum 5 digits, and then rounded to 3 significant figures for the answers that require it. Just with IB specifications, I would always recommend writing your answers this way, an unrounded answer first, and then your 3 significant figure answer. Now for part B and C, we're going to go do those ones on the calculator. I'm just going to write their answers though in here to straight away to 3 significant figures. Let's go to part B. Now with this part B, we have got a frequency table. Once again, let's put all our frequency table in there. Even though our score is horizontal and frequency is horizontal in the table, we can just write those in a vertical table. So our score will be in the first column and our frequency will be in the second column. So we're going to put those values in now. I've got my frequency table in there. I'm going to go to menu, just as before, statistics, stat calculations, one variable statistics. This time we need to make sure our data is in column A. Now we've got a frequency table, so we're going to put the frequency in column B. That's where our frequency values are, and our results are in column C. All looks good. We have our information. Now to find our standard deviation, we need to find this one here with the standard deviation symbol. And we can see there that is 2.80136, or 2.80 to 3 significant figures. Our variance, we're going to do just as we did in the last example, equals what cell is our standard deviation in. It is in cell D6, and we want the variance, so we need to square that. And our variance is 7.85 to 3 significant figures, and then range and interquartile range, the same thing. Now our range and interquartile range, let's work those out. So the range is our max, minimum, min. So another thing you can do with this, if you didn't want to type in D12, you can just go and select that cell. So because we want D12, then we want minus the min, which is in D8. Select that. I can use my cursor to go over to it and select it, and it will put D8 in there for me, and then press enter. And we can get our range that way. Into quartile range, we want Q3. So if we do it that way, we can hover our cursor over the quartile 3 value, press enter, minus the quartile 1 value, and then calculate that as 5. They're the solutions for part B. Now for part C, you see here we've got a grouped frequency table, which means we will need our mid values for each of our intervals. So between 2 and 3, the mid value will be 2.5, next one will be 3.5, 4.5, 5.5, 6.5, and 7.5. So now I've got my mid intervals, I can go put them into my calculator, which means we need to put in our mid values as our first column. Now we've got all our data in, let's do our calculations. Column A and column B for our 2 bits of information. And let's find our standard deviation. Here we are. So our standard deviation is 1.1. Our variance, standard deviation squared. So we want to equal our standard deviation, which is D6 squared. Press enter. 1.21 for our variance. Then we can work out our range and interquartile range. So our range, our maximum, minus our minimum, and then our interquartile range, our quartile 3 minus our quartile 1 is 1. And that's everything that we need to find. And then the solutions to part C. Alright, next little bit. If we add or subtract a random value k from each of the numbers in a data set, then the mean will also increase and decrease by the same value, but the standard deviation and interquartile range will not change. But if we multiply each number in a data set by k, a constant, then the mean, median, standard deviation and interquartile range will also multiply or divide, depending what it is, by that same value. So here's the example. Part A, the mean of a data set is 12 and the standard deviation is 15. If 100 was added to every data value, what will be the new mean and standard deviation? Now, because we're adding, it means the mean is also going to go up by the same amount. So if our original mean was 12, we're adding 100 to every value. Our new mean would just be 12 plus 100, which is 112. Now, because we've added 100 to every value, the spread of the data hasn't changed, which means our standard deviation will stay the same at 15. Part B, the median is 2.4 and the interquartile range is 3.6. If every data value is halved, find the new median and interquartile range. So if we're halving everything, that also means our median is going to be halved. So it'd be 2.4 multiplied by 0.5 or a half, which would give us an answer of 1.2. Then the interquartile range would also change because the spread of the data is going to decrease when we're halving everything. So our interquartile range will also halve, which will give us 1.8. And that's measures of dispersion. I know we talked about outliers in this video, but if you go on to the next video on presentation of data, that's where we'll really look at the outliers.